Alrighty. All right, number 7. I guess we stopped on 6, I think. So let's do a couple from 7 to 4. First one will be just something simple, and then we'll do a proof, and we'll go to 7 to 5. Okay. Also, we'll start to open up all chapter 7 until Sunday. Okay. I think 7 to 5 is Monday. All right, so here we go. So change this into a sum. We have a product of cosine and sine. Just remember this is your alpha and your beta. So apply your formula and just simplify it. That's it. So if it turns out that too many hard questions, I might throw something like this in there. So trying to decide how many proofs, how many equation types, how many simplification, because we only have an hour and change. So I'm gonna try my best to keep it balanced. I don't want to make an insane exam either. It will come from our review and our homework. Go from there. So this is the formula for cosine sine. So just simplify and leave it as exact solutions. This would be sine 1/2 times sine of 60 minus sine of 30. So sine of 60, that's going to be square root of 3 over 2, right? Minus 1/2, which is basically just square root 3 minus 1 over 4. Any question on number 7? Is it okay? Yes.
The test. When we put on decimals for the sin 60 and sin 30, fractions or
If it says exact, it has to be exact. If it doesn't say, then you can use decimals. Okay. So just make sure you read what it requests. I'm pretty sure most of them will be exact. But you don't have to go, you don't have to simplify too far. If you go a few steps, it's fine. Like if you stop right here, I'd be fine with that. All right. Prove the following. Sine x plus sine 3x equals to 4 sine x cosine squared x. I think the left would be good because we can do a sum to product. Whenever I see a 4, I'm like, that looks complicated. I don't know how to force a 4 to appear or turn into something like this. Well, I see it can be done. It just you have to be a little creative here, but this is more straightforward. Okay, this is just a formula, not too challenging. So I'm gonna start right here. So on the exam, make sure you start out by writing one side and then start. Do not work on both sides. Okay. Pick one side. All right. So sine, this is my alpha plus beta. So the formula for sine alpha plus beta is going to be 2 sine alpha plus beta divided by 2 times cosine alpha minus beta divided by 2. So I think that's right. All right. So to simplify this guy, that'd be 2 sine 4x over 2 cosine negative 2x over 2, which is 2 sine 2x cosine negative x. So right here we used sum to product, right? That first line. After that, we're just doing algebra. On line 3, though, how do you deal with that negative angle? Do you remember?
Look at even or
Yeah, this is even odd properties, right? Cosine is even, so it should just absorb the negative. Same thing as positive half, right? Even odd properties. So at this point, what do you think we should do? We're almost there, right? We got a 2. That's cool. What would you try if you were on the exam and you were here? Yeah, if you see a double angle, that may be a good thing to try, right? Just try the double angle formula. See what happens. So this would be 2 sine, well, actually, that 2 is already there. Let's put this in parentheses. This will become 2 sine cosine cosine. So I changed the double angle for sine. Now notice I'm going to get my 4. Looks like we're good. So 2 times 2, cosine times cosine. We got what we wanted. Does that make sense? Any steps that you missed or don't understand or strange? That, so this right here is the double angle. Sine 2x is equal to 2 sine cosine. So right here, I changed this one there. And that 2 is still here. See that? So I'm just changing the inside part there, and then just everything's being multiplied, so combine what you can. That's it. That makes sense? Okay. Let me turn the page then. Let's move on to 7. Well, we still have one more that I picked. You guys cool on this page? All right. Just let me know. 7.4, it's another proof. Prove the following. Two tan, well, let's do it down here. 2 tangent times cosine 3x equals to secant x times sine 4x minus sine 2x. I guess the right-hand side looks easier because we have a difference. We can change that to a product, right? Sum to products. And over here, I have nothing but products, so it looks like we should mess with this inner part. If I would have chosen the left, I probably would have to expand the 3x and see and hope something happens. Something like that. But I'm going to choose the right. So sine 4x minus sine 2x. So use your formula on the parentheses part to change it into a product. So right here, this is my alpha and beta. This becomes, let's use a bracket here. This becomes 2 cosine alpha plus beta divided by 2 times sine of alpha minus beta divided by 2. So this is going to be 2 cosine 6x over 2 times sine of 2x over 2, right? So now we're kind of almost there. This will be 3x sine x, right? Okay. We have this cosine 3x, so that's good, right? I need a tangent. I have the 2 right here, so that's also good. So we got to do something about this secant. So the first step we used sum to product. That's what we did right there. And then we just did some basic algebra, got to here. So use the reciprocal and remember that secant is equal to this, right? These are all just products, right? So we can rewrite it this way. 2 times cosine times sine over cosine. Do you see that we have tangent right there? This right here is tangent, correct? So we're going to have 2 times cosine times tangent, which is what we wanted to show. So right here we use the reciprocal. And then here we use the quotient or ratio. Does that make sense, or is that okay?
Does it matter if the 10 are like
Now you can always rewrite it because multiplication doesn't matter on the order. So 2 times 3 is the same as 3 times 2, right? Okay. No other questions? All right, so that's pretty much it for 7-4. I think half the homework was It's applying the formula, and then there was a few proofs at the end, right? So we'll pick something like that. You guys okay on this page? .5, solving trigonometric equations. We are on number 10. This was supposed to be 9, right? All right. Solve 2 cosine squared x plus cosine x equals to 1 for x between 0 and 2 pi, and then for all solutions. So this is in quadratic form. So solve this guy first. And the way we solve all quadratics is to set it to 0 and then try factoring. So this will be -1 equal to 0. So just subtract the 1 over. But this has to be factored like any other quadratic, okay? So well, let me do a substitution for you so it's a little easier. Let W equal cosine. So we have 2W squared plus W minus 1. Then just do any factorization method you want. I'm going to do the AC method that we teach in basic algebra. So 2 times a -1 would be -2. So the factors of -2 that add up to the center term, you put the sum over here, 2 plus that, 2 minus this, or -2 plus that. It's going to be the first one. So you break the center term into 2 minus 1. So this is broken into these, which came from here. Okay. These both have 2W in common. These two have a -1 in common. This will create a forced factor by grouping. So factor 2W, that'll give us W plus 1. Factor -1, that'll give us W plus 1. They both have W plus 1 in common, and you're done. If you want to do a forced trial and error, that's fine too. I don't care how you factor, just get it done. When we don't have a 1 in front of the square, I prefer to use this method. So if it was like you multiply the leading coefficient with the constant, and then you find all the factors. Okay, that's all, in case you forgot. Once it's set to 0, or factored, you can set them to 0. Solve for W. The W was made up, so bring back cosine. So where is cosine equal to -1? From 0 to 2 pi. It's only one spot, right? Where's cosine a half? Should be two spots. Two angles. Pi over 3. And what's the other one? 5 pi over 3. Okay. So these are all the angles within 0 and 2 pi. That give me a half or give me a -1. So that's these. Now just use each one of those and tack on the 2 pi k, and you'll be done. So we'll call this x1. This would be pi plus 2 pi k, 2 pi thirds plus 2 pi k. X3 would be 5 pi thirds plus 2 pi k, where k is any integer. Is there any questions on any of the steps?
How do you know when to use the formula where like you turn cosine to like W?
You don't have to do that. That's just to make it easier. But the idea is whenever you have any quadratic, it doesn't matter if it's cosine or x or whatever, you do factoring. So factor this like you did back in like, I don't know when you first did that. Freshman year maybe, right?
Right.
Forget. I don't know. Back in the day, right? When you factored this, doesn't matter if it's a cosine or a w, you would do the same thing. But I use the w just to make it easier for you. You don't have to. You could jump straight from here to there if you want.
Okay.
But just remember that if you see a quadratic, you follow the quadratic rules, right? Set it to 0 and factor. Okay. That's what you need to know. All right. You guys cool on this page? I think we got covered mostly everything already. I just want to rehash when we have to use our calculator. So to solve this, so we have to use inverse sine on our machine. There's no choice because it's not on the calculator, or not on the circle, I mean. So then x is equal to sine inverse of 0.27, which will give us, I don't know, something. I don't know what that's going to be. $15.7. Okay, so our first angle is 15.7 degrees. X2 will equal 180 minus 15.7, which is 164.3. So remember, I gave you notes for sine when you're doing the calculator step, and notes for cosine. So make sure you look up the cosine. I'm just going to do the sine right here. But there's something I didn't mention. If your sine is negative and you do your inverse, you get x equal to a negative angle. So if your angle is negative, what you can do here is add 180 instead of subtracting like we did over here. So just take this angle plus 180. So x2 will be 146.6. If you want the coterminal that's positive, that's stuff from test 1, right? Just add 360. You'll be done. So 326 and 446.6 will be the positive angles that give me negative sine 0.55 or negative 0.55. Does that make sense?
Can we just figure this to make it? So, yeah.
I'm cool with either one. Just make sure you know how to find the other one. That's what you're gonna need this.
Let's see.
Anyway, we'll we'll stop here. Do you guys have any questions from your homework that you're struggling with? Doing okay? Right. Well, we got plenty of time. If you want to stick around, you can. And if you want to head out early, you can. I'll be here for a while. Okay.